composite rod. A composite rod is made by joining two rods of different materials and same area then increase in length delta L equal to general formula L alpha delta T. So that equal to L1 alpha 1 plus L2 alpha 2 into delta T. L1 alpha 1 plus L2 alpha 2, that equal to L1 alpha 1 plus L2 alpha 2 into T2 minus T1. This is the delta L. So composite rod of change in length G, common temperature. So next one, common temperature. Two different materials. Right. Common temperature of the rod. Next application, common temperature. Of the rod. Right. For the rod of coefficient of linear expansion. For the rod of coefficient of linear expansion. For the rod of coefficient of linear expansion. Alpha 1 that has length L. At a temperature T1 degree C. Right. Its final length is L dash. At higher temperature is T. Okay, for first rod. The two rods, length same, LL, initial length. Temperature T1 or T2. Rise of temperature or same temperature. And the initial temperature is different. Maybe T1, this is the T2. But final temperature is same. Final temperature, T2 degrees is same. So for first rod, so L2 is equal to L1 into 1 plus alpha. So T2 minus T1. So L dash is equal to L into 1 plus alpha 1 into T minus T1. So T minus T1. So L into 1 plus alpha 1 T minus T1. For second rod. L dash is equal to L into 1 plus alpha 2 into T minus T2. Right. From equation 1 and 2, L into 1 plus alpha 1 into t minus t1 equal to L into 1 plus alpha 2 into t minus t. So LL cancel. 1 plus alpha 1 into t minus t1 equal to 1 plus alpha 2 into t minus t. So 1 cancel. Alpha 1 t minus alpha t1, alpha 2 t minus alpha 2 t2. Right. This is our t. So next one, alpha 1 t minus alpha 2 t equal to alpha 1 t1 plus alpha 2 t2. So t common, alpha 1 minus alpha. So alpha 1 t1 plus alpha 2 t2. So t equal to alpha 1 t1 plus alpha 2 t2 by alpha 1 minus alpha.
Final temperature.
This is the final temperature. Common temperature or final temperature of the both rods. So alpha 1 T1 plus alpha 2 T2 by alpha 1 minus alpha 2.
Sir, 1 minute. Okay, sir.
Okay, next, original length of the rod. A, B, C, D, E, F, G, H. Last and final rod case. Original length of the rod. Original length of the rod.
Sir, only final formula is important.
Final formula important. Proof no need. Final formula important. Right. If two rods of same length, if two rods of same length, if two rods of same length, length L, having different coefficient of linear expansions, alpha 1 and alpha 2, if two rods of same length, another application, original length of the rod, next application. If two rods of same length having different coefficient of linear expansions, alpha 1 and alpha 2, are at the same temperature T1 degree C. At the same temperature T1 degree C. Comma. Difference in their lengths difference in their lengths. At higher temperature is given by delta L equal to L alpha delta T. So same delta L is equal to L into alpha 1 difference is alpha 1 minus alpha 2. Alpha 1 minus alpha 2 into delta T. So original length, this is a change in length, increase in length x. X is given x equal to alpha 1 minus alpha 2 into delta T. L equal to x by, so alpha 2 minus alpha 1 into delta T.
Sir, x is difference in length, na sir?
Yes, difference in length. X is the difference in length.
Sir, sir, in that equation, x is equal to L of alpha 1 minus alpha 2. Sir, then in the next equation, you wrote alpha 2 minus alpha 1, sir.
Anyone? Okay. Anyone? Greater value minus greater minus lesser. For example, alpha 2 is greater, alpha 2 minus alpha 1. Alpha 1 greater, alpha 1 minus alpha.
Okay, sir.
Without negative, positive value considered. Okay, right. Completed rod R application is completed. This is a very important average coefficient of thermal conductivity is very important. Alpha average.
Sir, even application is also average coefficient only, sir. Application is also about the average coefficient of linear expansion only.
Very important. Alpha average important. L1 alpha 1 plus alpha L2 alpha 2 by.
So L1 plus L2. Yesterday only you gave, sir.
Very important. Very important. One problem is there, Akash material under.
Sir, yesterday you said, sir.
Example 12.15.
Example problem. Today also send on. One problem is there, iron rod of 60 centimeter length, brass rod of 40 centimeter length, having same area cross section are kept in series in contact. Alpha iron and alpha brass are given. Okay. Example problem, Nana. One example problem. Right. Next one, next application number. Rod completed sixth complete, seventh. Right, seventh one. Moment of inertia. Main application, moment of inertia.
So ninth one it will be.
Ninth one, huh? Okay. Moment of inertia. This is the original topic actually in system of particle chapter. So moment of inertia.
Seventh one this year.
Seventh one.
This is seventh application only. This is seventh application, sir.
Okay, it's correct actually.
So you are going ABCD of GH, no, sir?
This is ABCD. It's a rod applications ABCD.
Okay,
right. So next one, moment of inertia of a rigid body. A rigid body. This is actually direct one problem. Second X is also one problem or concept. Actually, moment of inertia, original topic in system of particles. So momentum of inertia, parallax theorem, perpendicular theorem, number of applications are there, system of particles. So 80% chapter depends on moment of inertia concept. Okay, what is moment of inertia? For example, this is the one body. This is the one body. Number of particles are present in a body. For example, this is the M1, this is the M2, two particles. For example, first one particle. So m is the mass of the particle. Is placed at a distance r from, for example, this is the axis of rotation. For example, this is the axis. This is the body. So body is rotated around the axis. This is called rotational axis. Okay? Body is rotating. Okay. So for example, this is the any one object. One end of the thread or string is attached to the body. Other end is holding his hand. He is rotated. Circular path. So this is the body is rotating about an axis, about an finger. Same. So what is the S? I is equal to moment of inertia denoted by I. So I is equal to mr square. What is mr square? The product of mass and square of the perpendicular distance from axis of rotation. Or is the product of mass of the particle and the square of the perpendicular distance. Perpendicular distance from axis of rotation is called moment of inertia. So moment of inertia means I is equal to mr square. I equal to mr square. Right. This is the perpendicular distance. For body also sigma mr square. Sigma m means sum of the particles, sum of the mass of particles, sigma m. But only one particle considered, so I is equal to mr square. Write down moment of inertia. Only definition write down. Just only brief. The product of mass of the particle. The product of mass of the particle and the square of the perpendicular distance. And the square of the perpendicular distance. The product of mass of the particle and the square of the perpendicular distance from axis of rotation. From axis of rotation is called moment of inertia. Moment of inertia. It is denoted by I.
సార్ మెటీరియల్ లో ఏ పేజ్ లో ఉంది సార్ ఇది? మెటీరియల్ లో ఏ పేజ్ నెంబర్ లో ఉంది సార్ ఇది?
ఉండకపోవచ్చు.
These RPs are application.
మెటీరియల్ ఉంటాయని కన్ఫర్మ్ కాదు నాకు.
లేదు సార్, RP సార్ లేదు.
So I is equal to mr square, right? The product of mass of the particle and square of the perpendicular distance from axis of rotation is called moment of inertia, right? So there are two methods are there, Nana. One is the log method without log method. Two methods are there. First method, okay, differentiate on both sides. This is the first method. Follow first method. This is the first method. Differentiate on both sides. So differentiate on both sides. So delta I, this is a delta I is equal to, so m into 2r into delta r. And 2r r power 2 minus 1. Same nr power n minus 1 into delta r. This is the formula, general formula d dt of x power n is equal to nx power n minus 1 into dx by dt.
హలో
సార్
Just wait, call is there, na? Just wait, okay?
కూడా కొంచెం స్లో ఉంది.
Clear? Right. So m 2 into r power 2 minus 1 into delta r. So delta I is equal to 2 mr delta r. This is the equation 1, equation number 2. 2 by 1. Equation 2 by equation 1. Dividing 2 and 1. So delta I by I equal to 2 mr delta r by mr square. So mm get cancelled. So r square get cancelled. 2 into delta r by r. 2 into delta r by r. So 2 into delta R by R, right? But this is a length, but the linear expansion alpha equal to delta L by L into delta. Delta L nothing but delta R. This is the change in length, change in radius, same. Actually, what is the L? L equal to, for example, a wire is bent in the form of a circle. Wire, for example, is a wire. Wire bent in the form of a circle. So L equal to 2 pi R. So L is equal to 2 pi R equal. So this is also same. So 2 pi into R2 minus R1 by, so 2 pi R into delta T. So 2 pi cancel. So that equal to delta R by R into delta T. Same delta L by L. Okay. A wire bent in the form of wire bent in the form of circle. Circle of radius is R. Same. So delta R by,
is blur, sir.
delta R by R is equal to alpha delta. Right?
Video clear,
Sir, video clear లేదు
Yes, sir.
Yes, sir.
Again, reach a call వచ్చింది call is there. Okay. Call. Increases by
17th only, sir.
increase 17th, sir. Right. Third option, 2 alpha I delta T.
Yes.
2 I alpha delta T. Right. d x power n equal to n x power n minus 1 into dx. So second method. So m cancel, m also cancel. So I is proportional to R square. Take log on both sides. Log I is equal to 2 log R. So what is delta I? Delta I by I. 2 into what is delta R? Log delta R by R. So 1 by R into d. Actual formula, log I formula 1 by x into dx. So 1 by I into delta I. So 2 into 1 log R means 1 by R into delta R. So direct same. So delta I by I is equal to 2 into, so delta R by R means alpha delta T. Alpha delta T. So delta I is equal to 2I alpha delta T. They take log method actually in measurement chapter, based on measurement chapter. So this is a general differentiation method, measurement, units and dimensions measurements model, log method. Okay. After, so L2, I2 minus I1. So I2 minus I1 is equal to 2I1 alpha delta T. So I2 is equal to I1 into 1 plus alpha, 1 plus 2 alpha, 1 plus 2 alpha delta T. Continue. Delta I means I2 minus I1. Final inertia minus initial inertia. Right. Exercise 2, 17. rod bent in the form of a circle. So L equal to 2 pi r, circumference of a circle. Okay. So eighth one, effect of angular velocity of a rotating rigid body effect of angular velocity of a rotating rigid body due to thermal expansion. So due to thermal expansion. This is the topic also same system of particle chapter. So system of particles. Right, and this is also system of particles. It's in the bracket, system of particles. Chapter name, system of particles. Track one.
Third one also, sir. The third one also system of particles.
System of particles. The basic concept, original concept, system of particle chapter. The moment of inertia also system of particle chapter. Track one. Right. Actually, what is the law of conservation? Linear momentum completed. Same law of conservation of angular momentum. What is the law of conservation of angular momentum? So torque equal, actually tau is equal to dl by dt. L is the angular momentum. L is actually angular momentum. P is the linear momentum. L is the angular momentum. The rate of change of angular momentum of a isolated system remains constant in the options of external torque. So same linear momentum also same. In the options of external force, the rate of change of momentum of a isolated system remains constant. Is called a linear momentum. Here also same. If tau is equal to 0, if this is the law of conservation of angular momentum. So law of conservation of angular momentum. So formula one relation, tau is equal to L is equal to I omega. This is after relation. So tau is equal to, so dl by dt. So tau if tau is equal to 0. If tau is equal to 0 is equal to dl by dt. So that implies L equal to constant. So L means I omega equal to constant. L omega, I is equal to L omega. Right. So L omega, L equal to I omega is actually proven. So L equal to angular momentum equal to angular momentum. Angular momentum L equal to I omega. So I is proportional to 1 by omega, inversely proportional. Momentum of inertia is inversely proportional to omega, actually constant. So I is proportional to 1 by omega. Right. Take log on both sides are omega proportional to 1 by I. Log omega is equal to minus log I. And minus, okay, actually this is the inversely proportional, minus log I. Log omega means 1 by omega into omega. And 1 by omega, log x differentiation 1 by x into dx. So 1 by omega into delta omega. This is a very simple formula. Say minus 1 by I into delta I. So any1 is a simple, this is the formula, 1 by x into delta x. So 1 by omega into delta omega. So log omega equal to delta omega by omega equal to minus delta. Inversely proportional take minus. Directly proportional positive, inversely proportional is negative. So delta I by I. Omega by omega equal to, what is delta I by I? We know that delta I by is equal to 2 alpha delta t. But delta I by I is equal to
So mute everyone.
two alpha delta t. So, but delta I by equal to 2 alpha delta t. So, delta omega by omega equal to minus 2 alpha delta t. 2 alpha delta t. Alpha. This is alpha delta t. So, what is the delta omega? Delta omega equal to minus 2 omega alpha delta t. So, this is angular velocity. Angular velocity delta omega is equal to, right, 2 alpha delta t minus 2 alpha delta t. Okay, or what is delta omega? Omega 2 minus omega 1 equal to minus 2 omega 1 alpha delta t. Right, omega 2 is equal to omega 1 minus 2 omega 1 alpha delta t. So omega 2 equal to omega 1 common 1 minus 2 alpha delta t. This is the final angular velocity equal to omega 1 into minus 2 alpha delta t. Or omega 1 equal to omega 2 by 1 minus 2 alpha delta t. For binomial theorem, so binomial theorem 1 plus x whole power m is equal to 1 plus mx. Same way, omega 1 is equal to omega 2 into 1 minus 2 alpha delta t whole power minus 1. So minus minus plus. Omega 1 equal to omega 2 into 1 plus 2 alpha delta t. Okay, for binomial theorem. So 1 plus omega 1 equal to omega 2 into 1 plus 2 alpha, or omega 2 equal to omega 1 into 1 minus 2 alpha delta t. Either omega 2 or omega 1. Exercise 3, 17th problem. Exercise 3, problem number 17. 17 are different number. The sphere of coefficient of linear expansion alpha, mass m and radius are spinning about axis through in diameter when angular velocity omega, when it is heated such that its temperature increased by delta t, angular velocity becomes. Seventeenth one, third exercise 3. Third exercise 17. This is the answer. Omega 2 equal to omega 1 plus 2 alpha delta t. Or omega 2 equal to omega 1 by 1 plus 2 alpha delta t. Omega 2 equal to omega 2 equal to omega 1 by 1 plus 2 alpha delta t. Third exercise 3, 17. So next application, very important. Next, pendulum clocks, thermal stress and thermal force and bimetallic strip. So ninth one, very important, pendulum clocks, gunshot, for Akash material. Right. So next, a very important application. So gunshot application, very important application. Ninth one, variation of time period. Variation in time period. Pendulum clocks. So pendulum clocks due to thermal expansion. So due to thermal expansion. So this is the topic for actual thermal pendulum clocks. So very important, pendulum clocks, very, very important in solids. Expansion of solids, so pendulum clocks, measuring tapes and measuring scale, bimetallic strip, and thermal stress and thermal force. This is a very important. Right, variation in time period of pendulum clocks due to thermal expansion. Actually, time period. So time period of pendulum. So actually in simple pendulum chapter, oscillation chapter. This is the oscillation chapter. So 1 8 marks question to derive the time period of simple pendulum. So to derive the time period of simple pendulum. So T equal to pi root time period of simple pendulum, time period. Time period of simple pendulum. Pendulum. T is equal to 2 pi under root of L by G. This is the formula. Time period of simple pendulum. Actually, in oscillation chapter, 8 marks question. Prove. 8 marks. Gunshot question, fingertip question. So to derive the time period of simple pendulum, T equal to 2 pi root of L by G. So number of applications are T equal to 2 pi root of I by MGD. So by using compound pendulum, torsion pendulum, number of pendulums are there. So this is the simple pendulum T equal to 2 pi root of L by G. L is the length of the pendulum, G is the acceleration to gravity. What is the simple pendulum? This is the pendulum. A small metal sphere is suspended. A string is attached to one end of the string, other end is suspended from rigid support. This is a small metal sphere is attached to lower end of the string, other end of the string is attached to from rigid support. It is pulled to a side, just pulled to a side and released. Okay. It executes simple harmonic motion, to and fro motion. To and fro motion. So not a pull to side, pull to a side, a small angular displacement less than 5 degrees only. Less than 5 degrees. Not complete 90 degrees angle. Just only 90 degrees. Less than 5 degrees. Less than 5 degrees. Only less than 5 degrees. Just pull to a side and release it. So it executes simple harmonic motion, to and fro motion. To derive the time period formula T equal to 2 pi root of L by G. This is a 8 marks question. Actually, pendulum clocks made of actually some rods. This is the pendulum, simple pendulum. So simple pendulum means this is also bob, metal sphere. Thread is a thread. Actually, pendulum clocks in wall clocks. Some is rod based on rods. This is the rod. Some based on this is the rod. Okay. Actually, in old houses, some kind of pendulum clocks based on this oscillation of the rod. Time to measure the time. So based on oscillations. Right. These rods are made of inverse steel, nickel plus steel, or silica. Okay. So these two, because of alpha, coefficient of inner expansion is very small. Alpha is very small. So, for example, made of other material without inverse steel, other material, either iron or brass, any material. For example, pendulum clocks are made of iron or brass. So, summer season, in summer, so length of the pendulum increases. Temperature increases in summer. So, summer season, so temperature increases, length also increases. Temperature increases, length increases. Length increases the time, okay, pendulum moves slowly. So time also run slowly. Okay? Then time also runs slowly. So because pendulum oscillations is slowly, length increases. So in winter season, so length is contract, length also contract. L decreases. So temperature decreases. Length also decreases. Length decreases. So pendulum oscillates with fast run. Pendulum oscillates with fast. Previous one slow is a fast. Run fast. Pendulum run fast. Previous one pendulum runs slowly because length of the pendulum increases. Temperature increases, length of the pendulum increases, pendulum moves slowly. So in this case, in winter season, temperature decreases, length of the pendulum decreases. So pendulum run fast. So time also fast. So this is the uneven. Okay, these are different times are measured in summer and winter. So to avoid this condition, summer and winter season, by using inverse steel. So coefficient of inner expansion is very small, either summer and winter season. Right. Okay. So, but a small either inverse steel also, but error not completely removed. Maximum error is eliminated. Maximum error. Small error is present. Small errors. Right. T equal 2 pi root of L by G. Equal 2 pi root of. This is the time period for simple pendulum. So loss of gain of time period calculated. Loss of gain of time period calculated. And loss of gain of gravity calculated. So number of again applications. So first one is A. So T is proportional to, T proportional to 1 by root G. T is proportional to 1 by root G. L is constant, T is proportional. 2 pi is the constant, T proportional to 1 by root G. T proportional to 1 by root G. Right. So T is proportional to G power 1 by, so G power half. Or T proportional to G power minus half. Take log on both sides. Log T equal to, so minus 1 by 2 into log G. Log A for N formula, N log A. Right. So log T means 1 by T into delta T. So 1 by T into delta T. So minus 1 by 2 into 1 by G into delta G. So delta T by T is equal to, so minus delta G by G. So 2. So 1 by 2 into, so minus 1 by 2 into, so delta G by G. Right, delta G by G. This is the formula. Right. So delta G by G equal to, delta G by G equal to, so 2 into minus 2 into delta T by T. Delta T by T. Okay, percentage calculated, delta G by G into 100 is equal to minus 2 into delta T by T into 100. What is the delta G? G dash minus G by G. So G is the acceleration due to gravity, 9.8 standard value. G dash is either increases or decreases. Either increases or decreases. Okay, right? So into 100, that is equal to minus 2 into delta T by T. So one problem is there in PDF or maybe workbook or PDF. Not PDF is there in one problem. Simple. Actually, question paper problem. So delta minus G dash by G, G dash minus G by G equal to minus 2 into delta T by T. Is the percentage calculated? So error calculated. No problem. Delta TT also same. This is the formula or anyone? This formula. Okay, this is the one relation only now. Tell me, Nana. Hello?
10:30, sir.
Okay, Nana. So tomorrow we'll continue.
You sent the PDF, sir.
Today send, Nana. Today 100% send.
Okay.
Okay?
Thank you, sir. Bye, sir.
Okay. Bye.
Thank you, sir.